Okay, I had to grab the other part of the book for the last one that we're trying to prove. But the second one we're trying to prove is 5.6. So I'm going to just go out over here. I'm just going to write it out. So 2, the integral from 0 to infinity of Vx g of Vx dVx is 2 kBt divided by pi m square root. Okay. All right, so a little bit to go here. Let's start by substituting in what we know. So we have a 2, the integral from 0 to infinity. We have v of x, and then g of v of x is what we've covered before, same as before. We have our constant, which is 2, or m, over 2 pi kbt, it's a square root, times e to the minus mvx squared over kbt dv dx. Or dv of x, I suppose. Okay, well, I'll pull out the constant. So we have 2, the square root of, and that 2's over here, it's being multiplied, m over 2 pi kbt, or I'm going to write this a little differently, times m to the 1/2 over 2 to the 1/2 pi to the 1/2 kb to the 1/2 and t to the 1/2. And we still have our integral from 0 to infinity vx e to the minus vx squared over k dt dv dx. So just keep in mind that this is our what's out front. I wrote it like that because it'll simplify a little bit, but right now I just kind of want to focus on the integral. And we're going to use this one because we have an odd power with our x. So I'm just going to, I'll write it back down over here. The integral from 0 to infinity of x to the 2n plus 1, an odd number, odd power, which we have, e to the minus alpha x squared dx is equal to n factorial over 2 alpha to the n plus 1. Okay? Where this is like our x, this part, actually, let me fix that. Oh, they don't include the negative, actually, so I had it right the first time. This is our alpha. So, if that's the case, 2n plus 1 must equal 1, since that's the power of our x. Or just n equals 0, which is fine. And again, alpha is going to be our m over 2 kbt. Forgot to put a 2 in here. There we go. There we go. Okay. So we have that. Now we can kind of substitute this in, right? I'm just going to call this C for now. So C times n factorial, that's 0, so that's going to be just 1, over 2 times alpha to the first power, which alpha is m divided by 2 kbt, right? I think we can see the 2's drop, and we have C kbt over m. And just real quick so we can see, this will drop with this. This is a 1, so this becomes 1 minus a half, which is 1/2. So that will go under the radical. That's why I wrote it that way. So we have 2m divided by pi kbt. And that's all the square root. So that's your c. Times kbt over m. Or what I'm going to do is I'm going to flip this and change my exponents. So this is to the -1. Everything's now to the -1 because I flipped it. Okay? So what do we have? We have the square root of 2 times the square root of m times, I'll rewrite this as the fractions. Right, we got that. Over, I'm just gonna do 2 pi. That's all to the 1/2. Oops, not 2 pi, that's my fault. There we go. Let's see, so we have this. We have pi to the 1/2, kb to the 1/2, t to the 1/2, right? And then we have kb, the -1, t to the -1. So I think you can kind of see what's going to happen is if you were to combine these, so like this and this, right? That's just going to be 1 minus a half. I'm sorry, -1 minus a half. So that's going to be, you're going to have 1/2 in the numerator. We'll move it up. And what we end up getting is the 2 stays up here. Like I said, the kbt goes back up because we flip it. The pi doesn't get flipped, it stays down there, and then the mass gets flipped back down, and that's all under the radical. So this doesn't have to be flipped, this doesn't have to be flipped. These two, you're gonna get -1/2, so that goes in the bottom. And that was what we wanted to show. So awesome. Now for the third part, I'll just do that really fast as well, get it done with. We have f of v dv, which is here. You could imagine what happened if we would divide by dv. And basically, the v max is this, which we know it even says here, is taking the derivative and setting it equal to 0. So essentially what we have to do is find f of v, find its derivative, set it equal to 0, and solve for v. So let's go ahead and do that. So I'm going to just write it down. V max is 2 kbt divided by m. It's all under the radical. And f of v, if we took that equation in the book and divided by dv to get f of v by itself, we'll end up with just this equation that I'm writing out now. So we need to take this derivative and set it equal to 0. So df by dv is equal to, I'm going to move the constants out front because derivatives are linear. That's okay to do. So this stuff is all constants. And then d by dv of v squared e to the minus mv squared over 2kbt. And that's all going to be equal to 0. So we have a product rule. Nothing too crazy here. I'm going to go ahead and just divide this out. There's 0 on the other side, so that's fine. So that's going to go away, and hopefully that makes sense on why. We can just divide that out. So derivative of the first, 2v times the second, e to the mv squared over 2kbt, plus the first times the derivative of the second. So plus v squared times the derivative of e to all this. Well, it's going to be just e to all that times the derivative of up here, which is going to be minus 2mv divided by 2kbt, and that's still equal to 0. Okay, well, these 2's drop. A negative I can put out front. So there's that. And I can move this whole side over to the right. So 2, I'm going to also do one more step. I'm going to divide out by a v. So 2e to the minus mv squared over 2kbt is equal to ve to the minus mv squared over 2kbt. Also, this drops, right? So that drops, and we have... Oh, duh. I went slow. I should have went slower, I meant. On the right-hand side, we still have plus mv over kbt. Okay, so we can divide by v, that's fine. We can move that over. We do get this. We do get this times this, so that drops. And we get 2 equals, that's just going to be v squared, because there's also a v here, m over kbt, or 2 kbt divided by the mass square root is your velocity. And there we go, we showed it. So basically just taking some derivatives there, not too bad. And there we go, we proved those 3 important